Lifesaver. We are live, ladies. So be careful what you say. Just kidding. Okay, part 2. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? And I said that 1, you need to have a simple random sample. 2, the population standard deviation needs to be known. And 3, the population is either normally distributed or greater than 30 according to the central limit theorem.
Yeah.
Awesome.
I agree with that.
I love it when we all agree. Okay.
Susan!
Hello, Susan.
Hey, how you doing?
Good.
Are you so excited to do statistics today?
Apparently you are.
No, I was just relieved to be invited. I was starting to panic. So thanks for doing that.
Yep.
How you doing?
Good, good.
How are your children?
Good, good.
I don't have any grandchildren today, so it should be quieter. I'll try to behave.
Oh, that's kind of sad. So, Susan, we had started the first one, so do you have yours up and we'll double check and make sure you have the same answer?
Oh, for part 2?
Uh-huh.
Um,
This would actually be question 6, not question 1.
yeah, the 3 assumptions. A simple random sample was drawn from the population. The distribution of the sample mean is normally distributed, and sigma is assumed to be known.
Perfect. All right, who wants to do number 7? It's a hard one.
I know.
Okay.
541.
Correct. At least that's what I said too.
I had to make myself a note that the point estimate is the same thing as the sample mean.
Okay.
Like point estimate, X, U, they're all the same.
Right.
I should write that down. Okay. Are we ready for 8?
Yeah.
Okay, create a 95 confidence interval for the population mean. So I guess I can say my answers and see if everybody got it. 532.13 and 549.87.
That's what I got.
That's what I got.
I haven't. Does everybody know how to do it?
I hope so.
So, like the 95% confidence interval is 1.96, and you times that by the standard deviation divided by the square root of 50. So I guess the sample.
Yeah, your sample size.
And then you take that number and you add it and subtract it from the population.
Sounds good.
Okay.
And then the next ones will be the same, right? With various different plugins.
Right. Yes. Divided by the square root of 100.
All right, number 9.
Okay, so I haven't actually done any of these, so
Okay.
I'm just working it out now. So for this one, are we doing that big long equation?
Yeah.
Okay.
Yeah.
So the sample mean 541 minus z, which, what was that again?
1.96.
1.96 times the standard deviation, 32, over the square root of 100.
Mhm.
Sorry, guys. I'm
Fine.
pretty slow.
You're okay.
In fact, this calculator is not working very well for me.
We got the formula that I got, so we want to see if, does everybody want to see if they got the same answers then?
Yeah.
534.728 and 547.272.
Yep.
Yes. Do
Excellent.
they want us to round it? 9.
I don't think so, not for this part, because we're not looking for the how many we need, like the sample size or anything. We're actually just looking for the confidence interval. So those
Okay.
aren't rounded, is from what I understand. Are you guys thinking the same thing?
Yeah.
Okay.
Okay,
So-
so go
Hey,
ahead.
I just finally got an answer. So for the first one, it's 534.728.
Mhm.
Yep.
Okay, good. I'm doing it right.
Awesome. Do you want to do the next one and do that, or
Okay, margin error of 95, sample size of 50 compared to the margin error of 95 for sample size. So how does it compare?
Yeah.
I didn't actually write down the one for the sample size of 50.
oh, so sorry. I was asking if you needed both of the answers. I just wanted to make sure that you had the answers for that number 9 for both the plus and the minus.
Oh,
But
don't have both of them. I still have
so 10 for 10, what you just read, I put that as the margin of error is smaller than the sample size is larger. So
Oh, right. So
compare.
if the sample size gets bigger, then the margin of error gets smaller, right?
Yep.
Yes.
Okay.
So 11, I'll go ahead and read that one. Create a 90% confidence interval for the original 50 students. So instead, we did the same thing, 541 plus 1.645 times 32 divided by the square root of 50. And I used 1.645 as my z-score from the applets with the 90%. So I came up with the lower level being 533.556 and the upper level being 548.448.
That's what I had.
Yep.
Okay. 12. How does the margin of error for the 95% confidence interval that you computed in question 8 compare with the margin of error for the 90% confidence interval that you computed in question 11? And the margin of error for a 95% confidence interval is 8.87, while the margin of error for a 90% confidence interval is 7.47. And the margin of error gets smaller as the level of confidence grows smaller.
Sweet.
Okay. Number 13, the BYUI professor would like to repeat the experiment, but he wants to make sure that he has enough students in his sample to ensure his margin of error is 5. How many students will he need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval? And this one, I was a little bit confused on. Like, I tried to watch some of the videos, and but I was not positive. So I think it's a little bit different than what we've been doing, or like the previous problems.
Yeah, this is different. So do you need help on this one?
Yes.
Okay. what I did on this one is I'm looking for my sample size, and so I'm going to do n equals z times standard deviation divided by m, and it gives us m as the margin of error in the question. So my formula looks like this. 1.96 times 32 divided by 5, and you times you times that whole thing by not times it by 2, but to this you square it. And so my answer came out to be 157.35 or 158, and this is the one that we round up no matter what because we're looking for the sample size. So we want to make sure we have a big enough sample size always, so we always round it up.
Okay, and is it 32 over the square root of 5 or just 5?
It's just 5.
Okay.
So 196 times 32, and that's divided by 5, and all of that is in parentheses, and that's squared. So again,
Okay, and you got 157.35, and then you just round it up.
Yep. Do you guys have the formula for that? Or are you good?
I'm okay.
I got it.
I just wrote it down, so.
Okay, perfect. So when I told you the formula the first time, I forgot to say that that is squared, but you got that, right?
Right.
Okay, perfect. Does anyone have any questions?
I don't think so.
Beth, how you doing?
I'm slow, but I understand.
Okay. Do you need us to go over anything?
I don't think so. It's all just a matter of me actually plugging in the numbers to the calculator.
Okay. Sounds good. Is everybody ready to move on to the quiz then?
Yep.
Yeah.
Not the homework quiz, ladies and gentlemen, because I just clicked on that one. I didn't start it, though. Caught myself.
Where's Quinn today?
Quinn won't be with us for a while.
What happened to him?
He hurt his back.
Oh, no.
Apparently Quinn's having a worse day than I am.
Aw.
Okay. Number 3. Find the margin of error for a 90% confidence interval when a standard deviation is 50 and sample size is 25. Now round to 3 decimals. Okay.
For this one, we're going to do z times the standard deviation over the square root of sample size, right?
Yes.
And that's it?
Yes, so 1.645.
What was that number again?
1.645?
1.645.
Okay. Wait, 1.645, right?
Right.
Yeah.
All I heard was 45, and I'm like, no, that's not right.
Well, it's just because I was having a hard time hearing the last two numbers.
Okay, I got 16.45.
That's what I got.
That's what I got.
Yay!
Woohoo!
All right, who's next?
I'll go. Which of the following statements is true? The third one, X bar is a point estimator of mu, of the means.
Yeah.
Yes. I thought you were reading them all, and I
Oh,
was like,
no,
what?
it's the third one, the third line.
Got it. Got it.
If I read too many things, I get confused.
Okay.
Okay. So, number 5. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. Simple random sample of 64 and computes from 526. What is the lower limit of this confidence interval? So for this, we take 526 minus, let's see, 95, 1.96 times 113 over the square root of 64.
That sounds correct to me.
So that would be 498.315.
That's what I got. Yay!
Yay. I don't know how you guys get yours in the thing so fast.
I know, that's what I did. I was like,
Well,
I guess I
as
wrote
she was reading it,
tables,
I was
didn't
plugging into the calculator.
Oh, that makes sense. I was writing it down and then plugging it in. That.
So we got 498.315.
Yeah.
Yeah.
Okay.
Is it my turn now?
Mhm.
Okay, what is the upper limit of this confidence level? So we're going to do 526 plus 1.96, right?
Yep.
Yeah. Times, parentheses, standard deviation of 113 divided by the square root of 64, end parentheses, end parentheses. So that's 553.685.
Yeah, that's what I got to do.
Yep.
What I got. Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
It would
Increase.
decrease.
The width would decrease.
Yeah. What would happen to the width of the confidence interval if Gina changed it to a 99% interval? The width would increase.
Yeah.
Okay. Bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So is that like the last one we did on the...
Yeah, so that's using the n1, n times
Okay.
n equals z times q divided by m.
Okay, so if they are looking for a 95, 1.96
Times the deviation.
yeah, times 400 divided by 50 and then squared.
Yeah, so sometimes I look at these and I'm like, a standard deviation of 400 hours? That's ridiculous.
I know. Let's see, 245.862.
Did you square it?
Yes.
Okay. Because I almost forgot to square it.
I got the same answer, but it says to round it up to a whole number.
Okay, yeah, so 246.
Sweet.
Oh, yeah.
All right. the mean salary of actuaries is mean equals $100,000, and the standard deviation is 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with level of significance 0.05, and you collect a simple random sample of 36 women's salaries and find that the sample mean is 1,100 or 11,000. No, 111,000. What is the lower limit? Okay.
Oh my gosh, this is confusing. I think they're throwing extra things in at us.
No, stuff that we don't really need.
Trying to mess us up.
Okay,
Yeah.
so sample mean is 111,000. 1, 2, 3, 0. And we minus 95%, so 1.96 times 36,730.
Oh wait, what?
So 111,000 minus 1.96 times parentheses 36,730 divided by the square root of the sample size, which is 36. End of parentheses, end of parentheses. Okay, so the lower level is 99,001.5333. And we're rounding it to the nearest whole number. That's 99,002. Is that what everybody else got?
That's what I got.
Yay!
Sorry, what was your answer again? I was still plugging in.
99,002.
Okay. So my turn. Was the upper limit 95% confidence level? So I take 111,000. We're looking for upper limit, so I'll add 1.96 times 36730 divided by the square root of 36, parentheses. I got 122,998.46, and so that would be 122,999, right?
Yeah. That's what I got.
I thought it was just 998.
Well, you have to round it up.
I know, but it's only a 4/6.
You always have to round it up.
Or was that only when you're finding the sample size?
I don't know. It's throwing me off because everything we've done today, we've been rounding up.
I know.
So, but the nearest whole number, Susan is right, is 998. That is the nearest whole number. What was it asking for? Upper limit of the confidence interval.
Well, I'm just saying, since it's 0.46, it's not over 5, so it's not going to cause the next number to go up.
Yeah, no, I get that. My confusion is
They were having us round up no matter what when we were finding the sample. But I don't know if that goes the same for this one.
Let me look at some of the. The other one's fine, right? 99002 doesn't. That one's good no matter
Yeah.
what.
I
Yeah,
think so, yeah.
yeah, because that was 0.54, and that was up to the next whole number.
Okay, so on the question 9, it says round up to the nearest whole number, and on question 11, it says round to the nearest whole number. So if it wanted us to round up, would it say round up?
Probably.
And then give us an example saying, no matter what, turn it up. That rhymes. I should be a poet, guys.
I'm gonna
Remember.
go ahead and put 122998.
I am too. Just because.
That.
Okay. Number 12, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, X bar is normally distributed, and sigma is known. So it's all 3 of the, it's the 4th one, all of the above answers.
I do believe that is correct.
Oh, thank you very much.
All right. I'm going to go look through, make sure. Check. All right. We ready to submit, ladies?
So,
I already did submit. Susan was right.
You was right. Did you do it the other way?
What?
Did you do it 998?
Yeah, I did, and that was correct.
Yeah, that's what I did too. Mine, clicked it and I was like, oh, good. Good eye, Susan. Good eye. Your turn to save the group this time. Question. So I have a tendency to just start the broadcast if I don't know who's going to start it. And I'm a little worried I'm being a little bit too pushy. Does other people have a desire to start and lead?
no. Thank you every day that you're able to do that, because I wouldn't know the first place to start, so thank you.
I'm like the same way.
I wouldn't think I'm not
mind
thinking you're pushy at all. You're just being great.
And
Was
I'm
that
not
Kelly?
always on my computer.
What was that?
I'm not always on my computer, so it's a little bit more difficult.
So, but you wouldn't mind starting and leading, right?
If
I
you
was the one
set up, I can lead.
Oh, sorry, who said it?
I said that.
Beth.
I wouldn't mind doing it, but it seems like every time I try, nobody actually can get onto my video chat or something.
Okay, and Kelly, you don't mind leading, but just have a hard time setting up sometimes?
Yeah.
Okay. So, Beth, do you want to do tomorrow? See,
Okay.
here I am. I'm being pushy again. Sorry.
You're just asking questions. You're doing great.
Yeah, I'll try it tomorrow.
Okay. Let me know if something doesn't happen and you need me to set it up. Sound good? And I will keep my trap shut tomorrow.
No, 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 no.